you're about to hear is a recreation of a slideshow originally presented at the Autodesk World Press Days 2008 event in San Francisco. Terry Bennett, Senior Industry Manager for Civil Engineering and Construction for Autodesk, has played a key role in the multi-company effort described in the presentation to follow. And now, here's Terry.
Easter Island, or Rapa Nui as it's locally known, is the most remote inhabited place in the world. It's over 2,200 kilometers from the coast of Chile and the nearest population. The island is best known for its iconic statues called moai, which are placed around the island. But the island is also the world's largest open-air park that is literally covered with caves, petroglyphs, the rock mounds that are called ahus on which the moai sit, as well as the rock gardens and other artifacts. While many theories exist, no one knows for sure why the moai, some of which are over 10 meters tall and 86 tons in weight, were erected, but it is believed that they were to honor their ancestors. The petroglyphs, like the Birdman depicted here, houses, caves, ancient outdoor crematoriums, and rock gardens tell the rest of the story of how the people of Rapa Nui lived over 1,500 years ago. Now, the island is at a turning point. With the extension of the airport's single runway in the 80s to over 11,000 feet for an emergency backup landing area for the space shuttle, more people have access to the island. They are at risk of unknowingly destroying the landscape, the natural resources, and the precious artifacts of this UNESCO World Heritage Site. So what do they have to do? First is to prevent further damage to the environment and the landscape. For example, erosion is a big issue today. As the red clay runs off into the ocean, fish populations near the shores have all but disappeared. The slash and burn activity, which has triggered much of this erosion, has to be slowed. This is actually a picture of what much of the island looks like today after those techniques went unsupervised. You can see the challenges they have here to bring the ecosystem back from a near Martian landscape. To accomplish this, they must rebuild the natural resources and vegetation that once flourished on the island and now only exist in a private horticultural area. This is key to building back the island's sustainability. They must prevent degradation of historical sites, the reason the people come to the island in the first place, as the island is literally covered in archaeological significance that is often unrecognized by visitors. Improvements in the island's infrastructure is needed in order to provide reliable services such as clean water, electricity, phone and garbage removal in such a remote place, as evidenced by using this beautiful caldera as a landfill. Development on the island to support tourism, water, power, roads, hotels, etc. is needed, but must be done so in a sustainable way so it ensures that they are not doing harm to the island. The mayor of the island is very mindful of sustainable development and not wanting to have history repeat itself. There's a lot to do, and it's a complex balance of resources and impact as the island moves toward modernization and urbanization. But a sustainable balance takes planning, visualization, analysis, and simulation, and that's where the technology comes in order to help them experience their ideas before they are real. We started by forming a partnership with key stakeholders on the island. Archaeologist and coordinator of National Monuments for Easter Island, Sonia Haoa Cardinale, the mayor, Senior Edmonds, as well as the planners and designers on the mayor's team. We sent a team from Autodesk and our customer, Metco Services, along with our partner Leica to the island, where we established GPS networks and control points to tie both the RTK surveying and the laser scanning to a single datum. We did 3D data capture, both high resolution and long range laser scanning, as well as existing ground topography on critical and complex sensitive areas around the island. We worked with and trained officials on the island to use the data and the Autodesk technology to develop accurate 3D models. As an example shown here of one of the scans of the moai on Rano Raraku. Now, for the first time, they can see their island in 3D and can plan how future development should take place. By first visualizing the over 30,000 sensitive areas found to date that need to be avoided, to analyzing slopes combined with the satellite imagery provided courtesy of our partner iCubed, and bringing all this information together to ensure designs focus on preservation via sustainable design and development, tackling the most complex areas of the island. With these tools, they can visualize ideas and build support among the citizens of the island, key to sustaining their future. This is particularly important among the island's youngest citizens. They are not only excited about the technology, but if they are more engaged in planning for their future, the island stands a much better chance of preserving its past so that Rapa Nui remains Rapa Nui. This pressure of urbanization is not so different from other regions around the world, like this example shown here from South Africa. Making the move towards modernization without destroying their rich and cultural history is critical. And at its core, it's about careful planning, conceptualizing designs, innovative thinking, and the wise use of resources by understanding the impact of the decisions through sustainable design approaches and experiencing their ideas before they are real. What makes the situation on Easter Island unique, when you're 22,000 kilometers from another society, doing it right the first time becomes not just a matter of business, but a matter of survival, a best practice we can all take away.